All right, so really quick video here on 8.3. This is the area of composite figures. If you have any questions, make sure you write them down so we can discuss them, but I think you'll have a really easy time with this. First and foremost, there's a little bit of vocab here. Uh, a composite figure, a composite figure is made up of two or more shapes. So this is not your standard polygon, rectangle, triangle, parallelogram. This is when we get two of them or even more than that and we put them together in some way. Um, to find the area of a composite figure, we need to first break that shape into smaller pieces. So look for the pieces that were put together to create that shape in the first place. Then we're going to find the area of each piece. So we're going to use our normal area formulas for the smaller shapes. And at last, we are going to add them together. Now, you should see I have one bonus word here, subtract. We're going to talk about that one in just a minute. So let's take a look at an example of a composite figure. So this is a polygon. If we count the sides, we can see it has 1, 2, 3, 4, 5 sides. So it is a pentagon. It's not a regular pentagon that you're used to seeing because it has some sides longer, some sides shorter, and it has this concave piece here. So this is not a normal pentagon, but it is a pentagon. If we were going to try to find the area of this polygon, we would find our easiest way to do this is to just draw a line right here and break it into the two shapes that we can see. So now I see a rectangle, possibly a square. If I had some measurements there, I could tell you a little bit more about that. And here I have a trapezoid. It's a trapezoid that's sitting on its side. Now, for some of you, that's not the way you would break this up, and that's okay. Another possible way to break this shape into two is to draw your line this way. And now I have a nice long rectangle here, and I have a right triangle here. So different people are going to see different ways to break these into smaller shapes. And almost every time we can solve them in a couple different strategies. The one thing I would warn against would be breaking it into two rectangles and a triangle, because now you're kind of breaking it down into too many shapes and they're not really necessary. So try to break it into the least amount of shapes possible. Okay, I'm going to get rid of that line so we don't think that's a good example. All right, so let's do two really quick examples. So this is one of the shapes from the Chapter 8 note packet. If we counted the sides, 1, 2, 3, 4, 5, 6, this is actually a hexagon. Again, not the way you would normally see a hexagon, but it is technically a hexagon because it has 6 sides. So if I were going to break this into smaller shapes, I would probably just draw a line right there. Okay, when we do that, you'll notice that this 8 is broken into two smaller pieces. That's no longer 8 centimeters. It's this piece here plus this piece here. And remember, one of the rules of rectangles is that opposite sides have the same measurement. So this side of the rectangle and this side of the rectangle are both going to be equal or congruent, which means this piece here, I'm going to trace it in green, that piece is 4 centimeters. Now, if this piece is 4 centimeters, then the top piece has to also be 4 centimeters because they have to add together to equal 8. And I know it doesn't look like that in this drawing. This is not a well-drawn diagram. I did not draw this one myself. I took it from somewhere else. But it doesn't look like they're equal, but there's probably a star that belongs down here that says this is not drawn to scale. Okay, so these two pieces have to add up to equal that original length. And remember, the reason we got this 4 centimeter piece here is because opposite sides of a rectangle are congruent. Now, here's what I like to do to stay super organized. I like to name one shape A and the other shape B. You'll see how that helps us out in a second. And what I would do is I would find the area of A and the area of B and then add them back together at the end. So the area of shape A, I'm going to put an A for area and then a little a, a subscript A, to show which shape I'm talking about, is going to be base times height. Base times height here is 3 times 4 And 3 times 4 is 12. And remember, area is measured in square units. So this is square centimeters. Remember not to read that as centimeters squared. That is not correct. A square centimeter is a square that measures 1 centimeter on all 4 sides. So the area of that rectangle right there would be 12 of those square centimeters. Okay, now I'm going to do the same thing for rectangle B. Rectangle B, there's my A for area, my subscript of B that shows them talking about shape B. The formula again is length, base times height. The base is 5, the height is 4. 5 times 4 is 20. And again, our units are square centimeters because we're talking about area. Okay, last but not least, this is a composite figure, and we are taking those two shapes and putting them together to make our composite figure. So I'm going to add my two areas to find the area of the entire shape. So A plus B is what I'm going to do here, and 12 plus 20 is 32 square centimeters. Okay, so there's my final answer. That's what our work should look like when we do these types of problems. All right, don't stop watching yet. I have one more to show you. There's a totally different example on the next screen. First, we were looking at examples that we can put together to get the composite shape, like this one where we have two shapes and we stick them together and now we have a new shape. Now we're going to look at a different type of shape, different type of composite shape. This is a shaded region shape. So if you ever see a problem that asks you for the area of the shaded region, that typically means that we're doing a little bit of subtraction. So the first thing we want to do is we want to find the area of the outer shape, this outer guy right here. So I'm going to call that outer shape. That will be my shape A in this case. That's the whole outside rectangle. And then I'm going to find the area of the inside shape. And the inside shape is that other white rectangle. And instead of adding them together, I'm going to subtract, because this would be kind of like taking a chunk out of the outside rectangle. This almost looks to me like a door with a window in it. So this would be one big piece of wood to make that door, and then we'd cut out a piece of that wood in order to make the window. So we're subtracting here. So same situation. These are pretty easy ones because they're just rectangles, but we can do this with any shape. The big outside rectangle is rectangle A, and that's base times height, 12 times 10. We get 120 square meters. The inside shape is our smaller shape, our shape B, and that's base times height, 7 times 2, and that's 14 square meters. And now remember, we're not adding this time, we are subtracting, because it's like a big piece of wood that we're cutting out a piece to get that gray shaded region. 120 minus 14 is 106 square meters. And before I finish this video, which is almost over really quickly, I have students in the past that have asked me, how do you know when you see an M? Is that meters or is that miles? Well, typically M is going to be meters, and if I wanted to talk about miles and abbreviate that, I would abbreviate it MI, or I would just write the word miles. Okay, so that's how I knew that was meters. All right, so when you do your practice problems and your bookwork, make sure that you are paying attention to whether we are adding shapes together to create a new shape or if we are subtracting to get a shaded region.